Hello everyone. This session we will see what is the relation and their type of relation, and related to that we will see some previous year JEE question also. So let's try to first understood what is the relations. Relation is that suppose A and B two non-empty set are there. So let's assume A is the one set 1 comma 2 and B is another set A B C. Here we have taken A and B two non-empty sets. So first we have to find A cross B. A cross B, we need a Cartesian product of A and B. What is the A cross B? A cross B, this is known as Cartesian product of A and B. How to calculate? All possible order pair from A to B. So what it will come? 1A, 1B, 1C, 2A, 2B, 2C. How many elements here? 1, 2, 3, 4, 5, 6. Total 6 elements will come A cross B. This is known as Cartesian product. Cartesian product means all possible order pair from A to B. If we are finding A to B, A cross B, first element will be from A, second element will be from B. This is known as Cartesian product. Now, if we are going to write a relation R from set A to B, what is the relation set A to B? It is the subset of, we can say, it is the subset of A cross B. Then it is known as relation. So like we can write this way, 1A, 1C, 2B. See, this is the one relation from A to B. Why? Because all the elements of R is present in A cross B. Means what is R is the subset of A cross B. So we can say it is the relation from A to B. If I write this way R from A to B, if I write this way 1A, 1C, 2C, A comma 2. If anybody asks, it is the relation. It is not relation. Why? See, all the elements are present. But what about this A2? Here 2 comma A is present. Here A comma 2. So we cannot say it is the not subset of A cross B. So this is not relation and this is the relation. So simply, if they ask it is the relation or not, just we have to check it is the subset of A cross B or not. If it is subset, then we say it is the relation. If it is the not subset, then we say it is not relation. Now, here we are taking two sets. Now, we are going to take only one set, like from a single set, relation A to A. So, what it will come? Let's take only this set. We are going to check now A cross A. Let's one set is there A, B, C. If we find A cross A, what it will come? Total 3 elements are there. So 3 3 are 9 elements will come. A comma A, A comma B, A comma C. Next B comma A, B comma B, and B comma C. Next what it will come? C comma A, C comma B, and C comma C. It is the A cross A. If we are going to write relation R from A to A, then what? This set must be the subset of A cross A. Like here, if you write A comma B, C comma B. This is the what? This is the relation from A to B. Here, first element is known as domain, second element is known as range. So, it is the also relation. If we write this way R, A to A, what it will come? Suppose we write A comma B, B comma A, C comma A, and if you write D comma A. See here, A comma B, B comma A, C comma A, it is present. But what about D comma A? D comma is not present here. Means what? This is the not subset of A cross A. So this is not relation. So first relation, what we have to do? We have to find it is the subset of A cross B or if it is subset of A cross B, then we can say it is relation from A to B. Or if you are checking same set, relation from A to A, if it is the subset of A cross A, then it is called relation from A to A. Now, okay, now see this. Now one question came, how many relations possible in such way? So simply what is that? It is relation is what? Subset of A cross A. So we know that total number of subset, what is that? 2 power n. What is the number of element in A cross B? So how many elements? 2 power 9 elements. So total number of subset for this set will be 2 power 9. 2 9, what is the number of elements in A cross A? That is the total number of subset. Now, till now we have studied up to class 11. Now, in class 12, it start type of relation. So first relation start here. Type of relation according to their input output we'll see. So first relation is that. First relation in second PUC. What is that? Reflexive relation. Reflexive relation. Here we are talking relation about same set, means relation R from A to A. So reflexive relation, when it is called reflexive relation, suppose simply if A comma A belongs to R for all A belongs to A, means what? Each and every element of A related to itself, then this type of relation is called reflexive relation. Let's see one example. Let's see A is set our 1, 2, 3. So A cross A, how many elements will come? 3 into 3, 9 elements. So if you are writing relation R from A to A, then we are writing 1, 1, 2, 2, 3, 3. See. Or we can write some more also. 2, 3 also will come. So what we can say, see here, each and every element like 1, 1, 2, 2, 3, 3 are related to itself. So this type of relation we can say it is reflexive relation. Because what it says, each and every element related to itself, then this type of relation is called reflexive relation. So here how many elements? 3 elements. 1, 2, 3. So 1, 1, 2, 2, 3, 3. All are related to itself. So we can say this is the reflexive relation. Next one more topic, one more problem they ask. How many reflexive relation is possible? If A have n elements, like here A have 3 elements, A can be 4 elements, 5 elements, 6 elements or n elements, then how many reflexive relation is possible? So let's see. One more thing before reflexive relation, we can see one more relation, identity relation. Identity relation. Here what we are written, each and every element related to itself, then we can say it is identity relation. Reflexive relation, identity relation is if each and every element related to itself only, then we say it is identity relation. Otherwise we cannot say identity relation. Like this way, if you are writing 1 comma 1, 2, 2, 3, 3, then we can say this is identity relation, because here each and every element related to itself only, not other one. So we can say it is identity relation. And this is reflexive relation, because each and every element related to itself and some other also. So this is reflexive and this is identity relation. So in this way we can say that every identity relation is reflexive relation, but reverse not true. Means if it is identity, then definitely it is reflexive. But if it is reflexive, there is no guarantee it can be identity. See here, this is reflexive, but it cannot be identity because 2 is related to 3. And here it is identity 1, 1, 2, 2, 3, 3. So it is identity as well as reflexive relation. Okay. So I hope it is no problem. Now we are going to see if there are n elements is given in one sets, how many possible how many relation we can find which is reflexive. So let's see this. It is very easy. Just we can go for combination permutation. Suppose if A have n elements, so like 1, 2, 3 and 4 dot n. This is set A. So if we find A cross A, what it will come? 1, 1, 2, 2, 3, 3, 1, 2 like this. So we are going to make box like this. And so on like this we can make. See here 1, 2, 3 dot n. 1, 2, 3 dot n. What it will come here? 1, 1 here, 2, 2 here, 3, 3 and so on. Here what it will come? 1, 2 here, 1, 3. Here what it will come? 1, 2 here, 1, 3 here, like 1, 4 here. What it will come? 2, 1 here, 3, 1, 3, 2 and so on it will come. So we are going to find how many reflexive relation we can find it. See, reflexive we have seen that each and every element related to itself must be there. Means what? Total this diagonal must be there. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, n must be there. So total number of box how many? N into n. Total box equal to how much? N into n means what? N square. And this is how many elements? Diagonal elements? N elements. Diagonal elements? Elements equal to n elements. So if you remove this, how many left? N square minus n. See here. If you are going to write reflexive relation, so you must have to take this. For that, no option. So how many we can select? One way only. Because we cannot leave anyone, we have to select all. There is only one option. Because in reflexive relation, it must be present. But remaining how many left? N square minus n elements left. We can select them, we cannot select them. So for one, how many options is there? Two options. We can select, we cannot select. Total number of elements is how much? N square minus n. So total reflexive relation, how many it will be? Total reflexive relation. How many it will be? 2 power n square minus n. This is the total number of reflexive relation, because this n elements we have to take, for there is no other option. So one way we can take, and remaining n square minus n elements left. So for that we can take one element two way. We can take that, we cannot. So one elements are two options. So n square minus n how many? 2 power n square minus n. So this is the formula for total number of reflexive relation. Let's see one example, one small question. Suppose if A equal to given 1, 2, 3, 4. If they ask how many reflexive relation is possible, so n equal to how many elements? 4 elements. 1, 2, 3, 4. So what we need to write? 2 power 4 square minus 4. So how many it will come? 2 power 16 minus 4. So 2 power 12. How many reflexive relation are possible? 2 power 12 reflexive relation is possible. Any problem? I hope it is clear for that. Now we are going for symmetric relation. Now another type of relation is symmetric relation. I hope it is clear. I have seen many, even JEE also they ask how many reflexive relation are possible like this. So we using this formula directly we can remember, and I already try to explain how this formula will come. So how? I hope it is clear. Now we are going for symmetric relation.